Everyone, my topic is transaction management and state diagram. So here is introduction to transactions, a set of operations that are used to perform some logical set of work. A transaction is made to change data in a database, which can be done by inserting new data, updating the existing data, or deleting the data that is no longer required. For example, you are transferring money from your bank account to your friend's account. The set of operation would be like this. Simple transaction example: read your account balance, detect the amount from your balance, write the remaining balance to your account. These are the ACID properties. First ACID properties are atomicity. The entire transaction take place at one or doesn't happen at all. Second, C consists for consistency. The database must be consist before and after the transaction. I consists for isolation. Multiple transactions occur independently without interference. D consists for durability. The changes of a successful transaction occur even if the system failure occurs. So we go into brief. First is atomicity. What is atomicity? The property ensures that either all the operation of a transaction reflect in database or none. Either it execute completely or it doesn't a participant execution. Next, consistency. So example, a transferring $100 to B. A's initial balance is 2000 and B's initial balance is 5000. Before the transaction, total of A plus B is equal to 2000 plus 5000 is equal to $7,000. After the transaction, total of A plus B is equal to 100 is equal to 1000 plus 6000 is equal to 7000. Okay, there is no other transaction which change values of A or B during execution of T. Then the new value of A and B will be 1000 and 6000. That is, A plus B is equal to 7000. Third is isolation. A transaction shouldn't interfere with the execution of another transaction. To prevent consistency of database, that execute of transaction should take place in the isolation. Means no other transaction should run concurrently when there is transaction already running. Fourth is durability. Once the transaction completes successfully, the changes it made into database should be permanent even if there is any system failure. The recovery management component of database system ensure the durability of transactions. State diagram. During the lifetime of transaction, there are a lot of states to go through. These states update to operating system about the current state of the transaction. These are the decided regulation which decide the fate of transaction, whatever it will committed or abroad, as we see in diagram. First is active state. If the transaction is execution, then it is said to be active state. Parallel commitment state. Once the whole transaction is successfully executed, the transaction goes into partially committed state. Failed state. A transaction consider failed when any of the checks fail or if the transaction is abroad while it is in a active state. Fourth, commitment state. If a transaction complete the execution successfully, then all the changes made in the local memory during partially committed state or permanently stored in database. Fifth state is if the transaction fails during the execution, it goes from failed state to abort state, because in the previous state all the changes were only made in main memory. These uncommitted changes are either deleted or rolled back. Sixth state is terminated state. State of transaction reach terminated state which certain transaction which are leaving the system cannot be reset. So thank you very much. This is my project. Thank you so much.